something completely useless. So we're going to go through techniques of integration. And integration is finding this antiderivative. And a typical calc course, I love this section of the course. I just go through all these techniques of integration. They're like little puzzles. They give me a little rush every time I go through one of them. But here it's an applied class. So what I'm going to do is show you what's called a toy problem, just to give you the idea of how to do it. And then I'm going to show you how it applies to, for example, finding the area under a rock curve. So the first toy example is this one right here, that 2x plus 1 squared dx. You can actually check the work by using FOIL and expanding this out, and then you'll have everything will be powers, and you can find the antiderivative using the technique we used on Monday. But we're going to do this using substitution. It's a toy problem to illustrate how to do something step by step. So as usual, the first time I do this, it'll be step by step, so you can actually watch and see how to do this. The first step is it's just like the chain rule. You have an inside and you have to identify the inside. You're going now backwards from chain rule, so you have to find the inside here as well. And it's called often U substitution because we use the letter U to identify what's on the inside. So the inside stuff here is what? 2x plus 1. And the reason I'm asking you that is because I made up that word, inside stuff. It's not actually a mathematical term. I'm just hoping that you get what I'm talking about when I say inside stuff. U equals 2x plus 1. I'll slow down so you can write. I just saw that research study that says when students write, they understand more. Okay, so that's just step 1. Ward, we did a board talk on Monday for you. Yeah, remember you suggested that we do like a little bit, yeah, mix it in. Well, I took pictures of everything. I have to compile it and load it up. The second step, so I recopied what was at the end of the previous, knowing that you will probably be taking notes, so you have that 2x plus 1 there. The next step is to find what we call du. It's kind of like finding the derivative. So you find the derivative, and we call that du, but where there was an x, we put the dx. So du is equal to 2 dx. So I'm showing you methodology, and I'm skipping the theory, so you have to get me. Do you get what's going on? Brittany? You got confused. Look. Get it? Yeah, it's like when you take the derivative of 2x, what's the derivative of 2x? 2, right? So that's where the 2 came from. Other questions? Yes. So it's like, you shouldn't think of it this way because it's illegal to think of it this way, but if you had to find du dx, it would be du over dx is equal to 2, and then cross multiply the dx to both sides. But as a habit, as a rule, we call it the differential and we go straight through. The derivative of u is du, the derivative of 2x is 2 dx. If it was 2x squared, it would be 4x dx. So you'll get a chance, I'll show you a different one. I think for the most part, I'm going to give you stuff that's fairly easy to do because I don't have to make this stuff up to get it to be complicated. By itself, it'll be easy. It'll be tough. The next step is to solve for dx, and that's why we have it separated like this. Dx is 1/2 du. And notice that I put it as 1/2 du because someone in here is going to ask me, even though I'm just going to tell you right now, can I divide by 2? Yes, you can, but it's going to give you some pain later on. So multiply by the reciprocal. It's going to save you some grief if you do it. These are also bookkeeping. I think when I told students that problem where you had a graph using derivatives is bookkeeping, and those students that believed me went through and just book kept when they practiced and thought of it that way, you could see the mentality was, did I make it to this point? Did I make it to this point? It is. It's a bookkeeping. This is bookkeeping. So once you've decided, the mental part is deciding that you need to use substitution. Once you've decided that, then it's bookkeeping. Okay, so now we have step 2 and 3. The next step is to do what we call change the limits of integration.
What if it was 2x squared? Would it be 4x?
Dx, yes. Next step is to change the limits of integration. So this was our original problem. The bottom limit is 1, the top limit is 2. I did that on purpose because your ROC curves, where do they always go? Where do they start and end? 0 and 1 always, right? So I just changed it because you asked me some questions about what if it was different. That's what it would look like if it was different. So that's what I mean by lower limit and upper limit, that x starts at 1 and x ends at 2. Well, the whole idea of substitution, what does it mean when you talked about substitution? Remember the substitution method from when you were in Math 100 or high school? Do you remember what that was? You take something and you substitute it, right, into the other thing. So that's what you're doing. Your plan is to erase all the x's and replace them with u's. Those limits are in terms of x's. So you want to change those limits so they're in terms of u. And how you do that is my transformation is u equals 2x plus 1. That was my u that I set up. It was the inside stuff. So this is just a reminder what that was. The lower limit is found by plugging in your lower limit of x, which was x equals 1, inside that u, and you get a new lower limit that's u equals 3. My colleague just walked by and was wondering why Game of Thrones was on here. I saw his eyes go. There's math above Game of Thrones. Like the connection was being trying to be made. What is the most disconnected thing from math? We should put it up there next time. I'm trying to think what is most disconnected from math. You know what? Last week I was at my daughter's birthday party, and the boys were hitting the tennis balls above and trying to hit the mothers with the tennis balls as hard as they could. So after like a half an hour of that, I went downstairs and I said, anybody who hits a ball up there again will be sitting upstairs with me and doing math problems. You should see the fun just erode from that population. It just like sucked it out of them. I thought, should I have been using math as a punishment? I shouldn't have. I thought they would have leapt for joy and said, let me be the next one to hit that ball up and hit a mom because I'll get to go upstairs and do math with Dr. Thomas. Didn't happen. So I guess the opposite of math is fun, right? Upper limit's done the same way. You take that same transformation. The old upper limit was 2. You stick that 2 in for x, and you get your new upper limit, which is 5. Good? Got it, Jewel? That was Math 100. You just take the 2 here and you multiply both sides by 1/2 so that the dx is solved for. Usually what you did in Math 100 is you divided both sides by 2. I'm suggesting not to do that. You'll see why in a second. If you do that, it'll be more right. If you multiply both sides, if you multiply this side by 1/2, what happens to the dx? What's 1/2 times 2? 1. So I just get dx alone, right? So dx is isolated. It's called the reciprocal of the numerical coefficient. The numerical coefficient is 2. You multiply both sides by the reciprocal. And when you do that, it erases whatever was here and it puts it on this side, right? So I'm suggesting you do that for a reason. You'll see why in a second. Right, yes, you can divide both sides by 2, but somewhere along the line, you're going to have to recognize that the division by 2 is 1/2. So I've experimented on previous student sets, or that Calc 2 class, those Calc 2 classes, and I can tell you whenever they multiplied by 1/2, they got the answer right. Whenever they divided by 2, 50% of them get the answer wrong. So let's go the path we already know works. Okay. So now we're ready to make the substitution. So each one, you see me boxing things off I'm autopilot when I'm going through these problems because I've done them so many times. When I box something off, usually it means it was important, I need it later on. Because in all my work, I'm actually not a good bookkeeper. Maybe your math pre-calc teachers are better bookkeepers. I'm not a good bookkeeper. So I feel like I have to be even more careful because I'm not a good bookkeeper. And so what I'll do is I'll flag things off so I don't lose them somewhere. I'm talking about things like, my 1/2 was written messy and sometimes it turns to 1/3. Things like that happen to me. It's somebody else's fault. They just happen to me. So those are my new limits. That was my U. That was my dx. I'm ready to substitute in and change the whole thing. And so what I've done here is instead of the dx, I've replaced the dx with 1/2 du. I've replaced the 2x plus 1 with u. I've replaced the limits now with the new limits, which is 3 to 5. So there's a complete replacement of all that is x with all that is u. And when you've screwed up big time, if there's at this step, if there's still an x, you have messed up big time. Remember the 55 and below in Calc 2? Those guys would always have an x hanging around. And I would make the same announcement I did just now, that at this step, you should not see any more x's. Because that's the whole point. You're trying to get rid of the x's and replace them with u's. And why is this useful? Well, u squared, you can integrate, you can find the antiderivative using the backward power rule that I showed you on Monday, which you have had no time to absorb yet. But that's what we're going to use. The plan is I had something that looked a little messy, and now it looks a little better, and I can apply a rule to it. And that's another point I used to make to the Calc 2 students. If what you get at this step looks worse than what you started out with, you probably made a mistake. It shouldn't look worse. The whole point is to make it look easier and better. Please listen to the audio when you're doing this video, because I'm giving you tips. So just to show you with arrows, that's where those guys came from. They got dropped in. The u equals 2x plus 1 got dropped in. The dx equals 1/2 du got dropped in. So that's where I'm at now. I've got that guy. So now you do that antiderivative thing. The 1/2 just gets pulled out to the side because it's a constant. I don't have to worry about it. That's why the whole thing is you want to multiply by 1/2, because whenever people see the du divided by 2, they seem to be confused by what that is. Just call it 1/2 and pull it out. And the backward derivative of u squared is add 1, divide by that number. Remember we did that on Monday's class? Add 1 to the power, divide by the number. And see this line here? Remember you have to do f of b minus f of a? This is our shorthand notation just to remind us that we're supposed to take this guy over here, plug in f of b, and subtract f of a. It's just shorthand notation, just to remind myself that what I'm supposed to do next. And that's the f of b minus f of a thing. I plug in into u cubed, I plug in 5 for u, and into u cubed, I subtract plugging in the lower limit. And I didn't have a calculator sitting here and doing that. Am I okay leaving it? You can figure this out if you want to. It's a number. Some number. We can shout it out, it'll be on the recording. That's the backward, again, you didn't have time to absorb it yet, but it was Monday's class. Remember the backward thing, going from u to the n, how would you find the antiderivative of, right? You add 1 to the power, divide by that same number. So the power here is 2. To find the antiderivative, I would add 1 to that power, divide by that same number, right? Monday's class. Right. I knew that you guys probably were sitting around after class watching the videos and thinking about what we did in class, but because that is here. This is when we write this symbol, what it means is we're looking for the antiderivative. What that symbol means is what is the antiderivative of the gunk inside. So that's the antiderivative of the gunk inside is this guy. They're actually equal.
But just put the half to the side.
What do you mean?
So that equals half.
Because the half doesn't have any role inside, right? So again, from my experience with lots of students, when any number or anything's hanging around inside that you don't need to deal with, sometimes it's a bookkeeping problem. They incorporate it in some way they're not supposed to. So if it's not anything you have to deal with, push it out. That way, it is a bookkeeping problem. You know, it's not that dissimilar to when you teach someone how to play tennis and you tell them follow through, do the right things, and they just don't. And when you watch them play and you're like, man, I told them to hit it square. I told them to hold the racket and not use their wrist, and they're just keep doing it anyways, and they keep screwing it up. It's kind of like that. If you do best practices, you'll get it right. Like these things are long and windy. Yes, f of b minus f of a. It's if your integration goes a to b, it's the second thing first and the first thing comes second. That's why I wrote the f of b minus f of a. So again, you haven't had time really to absorb the Monday lecture, but you know, it's a lot of stuff. If I had there's no way you can do this without knowing what a derivative is first. So this is one of these things which I would not like to do in the last week, but I have no choice. It's just the order of things, right? It's hard stuff. I was just talking to Dr. Forgeston, who's across the hall from me, and I said, integration's actually hard. It's not easy. And he said, why do you think that? And I said, it's just like long division. Think about teaching someone long division. Once you know it, you know it. But teaching someone for the first time, when you watch their face looking at long division, you'll have to teach your kid. It's a very weird thing. And they're going to ask you, why you put that there? Why did you do that? It's not easy, right? So this is like the first, I'm looking at it through your eyes for the first time. Like, it's not easy. There's another person walking by. Game of Thrones. Are they having fun in there? Okay, so I'm going to give you another example without the steps in there. Let me hold off